In this video we're going to be looking at an equilibrium system using which two chemicals?
Iron 3 nitrate and potassium thiocyanate.
Well said. Okay, these two chemicals, when they react, they make an equilibrium reaction. They have an equilibrium reaction, becoming the FeSCN2 plus ion, which is a complex ion, so we put square brackets around it. And you can see it makes this really cool blood red colour. So I've tried to make 4 different solutions that are nearly the same concentration. What we're going to do is we're going to try to mess up those equilibria by adding certain things to them. So, keeping in mind that they're a similar concentration, we'll consider one of these to be our control. Let's say, for argument's sake, this is our control. Okay, so we're trying to see if it goes darker or lighter than that. So in our experiment, what was the first thing that we were told to add to it?
Iron 3 nitrate.
Okay, so that's one of the reagents on the left-hand side of our equation. So, Gabby, could you put a little bit of iron 3 nitrate in any one of those apart from this one? Yep.
How much?
As much as you'd like. And we observe that what's happening there?
It gets like a dark circle around.
Okay, it's got a lot darker. The dark colour is due to the complex ion, the iron 3 thiocyanate ion. So it means that it's making more of the products. So by adding more reagents, the equilibrium shifts in the forward direction to make more products. So the way that we say that is that by increasing the concentration of a reagent, it favours the forward reaction. Now it favours the forward reaction until a new dynamic equilibrium is created, and that'll be our new colour. So the more I swirl that, the more it should actually react until we get the same sort of colour through the whole lot. What was the next thing that we were told to do?
Add potassium thiocyanate powder.
Okay, so you can choose any one of those apart from the one you've used and the one nearest you from it.
That much?
If you like.
I'll just say much.
That's a good amount. Okay, so it takes a while to dissolve, and actually where it's dissolving it goes quite clear. That's because of the thiocyanate, which has no colour. But if we swirl it, we can see compared to our control, it's getting a bit darker, maybe a little bit more, just because it hasn't all dissolved yet. So again, like in the first one, not quite so dramatic because we're using a solid rather than a solution. But again, we're seeing that the forward reaction is favoured because if I add more of the reagent, the thiocyanate, it's favouring the forward reaction. Now, last one's a bit of a weird one. What's the chemical we're adding here?
Sodium fluoride.
Okay, now sodium fluoride will actually bind to iron 3 ions, but it won't bind to them if they're already in a complex. So it'll take away some of our reagents. Let's see what happens if we add that. Oh, this is going to be quite impressive. Go for it if you want to.
Yeah.
And here we can see that it'll probably go colourless actually in this case, because in this case we've taken it so far that we've actually bound all of the iron 3 ions out, and there's probably none there at all. So we've actually destroyed the equilibrium in this case. If we added only a small amount, the colour would just fade as a new equilibrium is established. All right, so I'll just show you what I mean by just a little bit on our control. Oh, don't be sorry. There was an apology there, but it wasn't needed. It was quite exciting to see it go the whole way. Okay, so you can see there that this is using up a lot of it, but not all of it, because it's still got a little bit of an orangey, reddy colour to it. Okay, so if we change the concentration of any of our species or our reagents, then that's going to have an effect on the equilibrium position. If we add one of the reagents, it favours the forward reaction to make more products and create a new equilibrium. Okay, so it actually re-establishes the original concentration balance. If we destroy or get rid of a little bit of a reagent, so lower its concentration effectively, it'll favour the reverse reaction. And that's the main thing that we want to get out of this equilibrium. So now, in the last 2 lessons, we've seen the effect of pressure and temperature on an equilibrium, and we've had a look at the effect of concentration on an equilibrium.